By the end of the next decade, the first human feet will likely touch down on the dusty red soil of Mars. This is NASA's timeline, and it is by no means unrealistic. And while that first visit might be similar to a stop-by in line with the moon landing, some scientists are claiming permanent human colonies could be set up on Mars as early as 2050. That means it could be you, alive today and watching this video, who is the one who sets out to tame that new frontier. You'd need to get into a space program pretty sharply if you're not in one already, but it is possible that you'll one day look out of a little bay window and watch as our pale blue dot vanishes into distant space. But as you turn your gaze to your new home, what conditions can you expect to find on Mars? What challenges face any would-be Martian colonizer? What deadly weather will you encounter? What will the red planet throw at you? Because unlike our home planet, Mars is a dead world, and anyone hoping to set foot there will need to overcome its daunting challenges with technology that is at the very cutting edge. The journey to Mars. To colonize Mars, you first have to get there. The trip itself would take about 3 months with the most optimal launch conditions. That doesn't seem too excessive. It's like a long voyage on a cruise ship. But you have to consider that you'd spend at least 3 months outside the safety of Earth's magnetic field. Out here, you're exposed to the solar wind and cosmic radiation. Prolonged exposure can cause astronauts to develop cancer and even symptoms of Alzheimer's before they reach Mars. Fortunately, there are some thoughts about how to protect against this. The astronauts could be shielded using materials in the ship's construction that are rich in hydrogen. In fact, the cabin could be surrounded by a water tank in the walls. Water being rich in hydrogen. Another option is to create a magnetic field around the spacecraft, but this requires generating a huge amount of energy from a reactor small enough to fit on the ship, something we don't have the technology to do safely just yet. Mars, the surprisingly familiar alien world. Once there, for an alien planet, Mars is not as foreign as you might think. Earth and Mars share a lot of similarities, one being the length of day. The solar day on Mars is only slightly longer than it is on Earth, 24 hours, 39 minutes, and 35 seconds. Its year is longer, 1.88 Earth years, or 1 year, 320 days, and 80.2 hours. But that's to be expected for a planet further from the Sun. Of all the planets in the solar system, the seasons of Mars are the most Earth-like, due to the similar tilts of their rotational axes, 23.5 degrees on Earth, 25 degrees on Mars. So what does that imply? It means Mars has summers and winters just like Earth does. These temperatures can vary a lot, with lows of minus 143 degrees Celsius, minus 225 degrees Fahrenheit, at the polar winter caps to highs of 35 degrees Celsius, 95 degrees Fahrenheit in the equatorial summer. Mars has polar caps just like we do. During each pole's winter, the pole lies in continuous darkness, just like on Earth. However, unlike on Earth, the temperature gets so cold that the atmosphere itself freezes into slabs of CO2 ice, which collects on the surface of the permanent polar caps, which are mostly made of water ice. One thing I love about Mars? These strange spiral patterns in the ice. Both poles show signs of these beautiful formations, which scientists believe are a result of the Coriolis effect, the deadly dance of dust storms. But the CO2 at the poles doesn't remain there forever. As it sublimates, turning directly from ice to gas, it has a knock-on effect on another aspect of the planet, its winds. Sublimation of dry ice can create enormous wind speeds, which fuels one of the most unique and terrifying aspects of Martian weather, its dust storms. If you peered across the rusted Martian surface through photos, you'd be forgiven for thinking Mars is a place of stillness, flat, dusty landscapes stretching out in all directions, with nothing but scatterings of rock and the faint whistling of the wind. But stay a while, and you'd soon see a towering wall of dust and sand brewing on the horizon. You might think to yourself that this dust storm is similar to those we see on Earth, and have no idea that this storm is about to grow so large. Its thick dust will swallow up not just a region, not just a continent, but the entire planet. These planet-enveloping superstorms arise on Mars usually every 3 Martian years, about 5.5 Earth years. Their choking dust blots out light for weeks, even months, and represents a huge challenge to any technology or humans on the surface. Why Mars has such violent storms? Mars didn't used to have planet-sized dust storms. Billions of years ago, it had a thick atmosphere, warm enough to support liquid water. But over time, Mars dried out, and its atmosphere bled away until it was less than 1% as dense as Earth's. Those dust storms didn't just start happening because Mars became dry, though. A key component is Mars's temperature. With so little atmosphere, Mars is terrible at retaining heat. If you stood on the equator during the warmest part of the day, your feet might feel 23 degrees Celsius, 73 degrees Fahrenheit, while at your head it'd be 0 degrees Celsius, 32 degrees Fahrenheit. These extreme temperature differences cause winds to form, driving dust into the air. And dust, not water, now drives Martian weather. The dust that swallowed a planet. Dust plays a surprisingly crucial role on Mars. The atmosphere is too thin to capture heat, but dust? That's another story. It all begins with dust getting into the air. One way this happens is through dust devils, of which Mars experiences thousands every year. These spirals of rising air can be hundreds of meters wide and 8.5 kilometers, 5.3 miles tall, sucking up dust and hurling it into the atmosphere. But the most common way dust gets airborne is through saltation, where wind lifts larger sand grains, which then crash down, kicking smaller dust particles up. Mars's low gravity means this dust can stay suspended for weeks or even months. And this is where the trouble begins. Unlike the thin Martian air, dust particles are excellent at absorbing sunlight. As they heat up, they warm the air around them, causing it to rise, which pulls in more wind, which kicks up more dust in a runaway cycle that can escalate into a planet-wide storm. The storm that killed a rover. These superstorms are bad news for technology. In 2018, one such storm killed NASA's Opportunity rover by blotting out the sun, starving its solar panels. The rover's batteries drained, and without power for its heaters, the cold wrecked its electronics. Even nuclear-powered rovers like Curiosity face problems. The dust is so thick it can block communications with Earth, and satellites orbiting Mars aren't safe either. The heated atmosphere expands, increasing drag and forcing them to burn fuel to stay in orbit. For human colonists, these storms would be a nightmare. Solar-powered settlements would go dark, temperatures would plummet, and with communications blocked, you'd be completely cut off from Earth for weeks. Could you really grow potatoes on Mars? Many of us have seen The Martian, a gripping film about surviving on the red planet. One key part of the story focuses on growing potatoes in Martian soil. But how practical is that in reality? Does Martian regolith actually have the nutrients needed for plants to grow? And would there be dangerous side effects from eating crops cultivated on Mars? As it turns out, Martian soil does contain many essential nutrients for plant growth, depending on where you land. Just like Earth, some regions are nutrient-rich, while others are barren. Researchers in 2016 successfully grew tomatoes, rye, radishes, peas, leeks, spinach, and quinoa in simulated Martian soil, with yields only slightly lower than in Earth soil. Interestingly, moon soil simulants produced about half the yield, with spinach struggling the most. But there's a catch. The experiment added organic fertilizer, chopped grass, to fluff the soil and provide nutrients. Without it, the plants would have died quickly. The hidden poison in Martian soil. Another problem, heavy metals and a toxic salt called calcium perchlorate. These compounds absorbed by plants could poison colonists if consumed in large quantities. But perchlorate isn't all bad. It can actually help survival. It sucks water from the air, which could be harvested. It breaks down into oxygen, critical for breathing. So how do we fix the toxicity? Two solutions. 1. Wash the soil, flushing perchlorates out with water. 2. Use bacteria. Engineered microbes could eat perchlorates, releasing oxygen as a byproduct. Why fresh food matters. Growing plants isn't just about survival. It's about mental health. Studies show that fresh foods like tomatoes, blueberries, and leafy greens boost morale and may even protect against radiation. For colonists trapped in a cramped habitat, A taste of home could be the difference between sanity and despair. Flying on Mars, the impossible feat. Speaking of ingenuity, pun intended, surviving Mars requires adapting to its unique challenges. We've been working with NASA's Jet Propulsion Lab to get exclusive access to Ingenuity, the first helicopter on Mars. Ingenuity used ultralight materials and twin carbon fiber rotors, spinning at 2,400 RPM, 5 times faster than Earth helicopters, to achieve 72 groundbreaking flights over 3 years. It traveled 17 kilometers and even scouted paths for the Perseverance rover. This tiny chopper proved flight is possible on Mars, opening doors for future aerial scouts that could map terrain or rescue stranded astronauts. Robots that walk like animals. Helicopters aren't the only tech being tested for Mars. NASA's JPL is also collaborating with Boston Dynamics, yes, the robot dog people, to develop walking explorers. Why? Because wheels have limits. Remember NASA's Spirit rover? It got stuck in soft sand in 2009 and never escaped. Later, Opportunity nearly met the same fate inside a crater. Wheels work great on flat ground, but Mars is littered with rocks, dunes, and steep slopes. Enter Spot, Boston Dynamics' four-legged robot. Unlike bulky rovers, Spot can climb stairs, rubble, and uneven terrain, self-right if it falls, operate autonomously, critical when Earth commands take 22 minutes to reach Mars. In a NASA-funded test, Spot teamed up with drones and other robots to map lava tubes, potential shelter sites for colonists, without human input. The cave dwellers of Mars. Why explore caves? 3 reasons. 1. Science. Caves preserve clues about Mars's wet past, and maybe even microbial life. 2. Shelter. Underground, colonists avoid radiation, dust storms, and temperature swings. 3. Resources. Ice deposits lurk in shadowed craters and tunnels, but caves are a nightmare for wheeled rovers. Tight passages, uneven floors, and zero GPS make them a death trap. Spot, though, could navigate them effortlessly, sending back 3D maps for future human missions. The communication problem. Here's the brutal truth. Mars colonists will be on their own. On Earth, calling someone on the other side of the planet has a split-second delay. On Mars, even at its closest, signals take 3 to 22 minutes one way. A simple, "Hello, how are you?" could take 44 minutes to get a reply. That means no real-time help from Earth. Emergencies, equipment failures, medical crises must be solved locally. Colonists need encyclopedic skills, doctors, engineers, farmers, all in one. Where will humanity's first Martian city be built? After surviving the journey, weathering planet-wide dust storms, and figuring out how to grow food in toxic soil, the next question is, where do we actually settle? Mars isn't exactly a real estate paradise, but scientists have narrowed down a few top contenders. 1. The North Pole. Water ice is abundant here, but the extreme cold and months-long darkness make it a harsh choice. 2. Hellas Planitia, one of Mars' lowest, and therefore thickest atmosphere, regions, offering slightly better radiation protection. 3. Lava tubes. These underground tunnels formed by ancient volcanic flows provide natural shielding from radiation and storms. Some are large enough to fit entire cities inside, but the most promising location might be Korolev Crater, an 81-kilometer-wide ice trap near the North Pole. Its permanent ice deposits could supply water, oxygen, and rocket fuel. The catch? Temperatures here plunge to minus 150 degrees Celsius or minus 238 degrees Fahrenheit. Building a home from red dust before humans arrive, robots will need to construct habitats, and NASA's plan is revolutionary: 3D printing entire bases using Martian soil. Here's how it would work. 1. Autonomous excavators dig up regolith, Martian dirt. 2. Processing plants extract metals and minerals, mixing them with water ice to create a concrete-like material. 3rd, giant 3D printers layer this mixture into dome-shaped structures strong enough to hold atmospheric pressure. The final touch? Burying the habitats under 3 meters of soil for radiation protection. This isn't sci-fi. NASA's already tested prototypes using simulated Mars dirt on Earth. The oxygen factory breathable air is non-negotiable. While plants will help long-term, the initial solution is MOXIE, Mars Oxygen ISRU experiment, a device on Perseverance that's already producing oxygen from CO2. Scale this up, and we could fill habitats with O2, make liquid oxygen rocket fuel, create emergency reserves powering a civilization's solar panels, unreliable during dust storms. Nuclear reactors? Perfect, but we'd need to ship them from Earth. The likely solution, a hybrid system combining solar farms for daily use, compact nuclear reactors for backup, massive batteries to store excess energy. The psychological war. All the technology in the universe can't fix human nature. Imagine being trapped with the same 20 people for years. No real-time communication with Earth. Constant danger with no quick rescue. The Earth out the window slowly shrinking to a pale dot. NASA's Antarctic and ISS studies show isolation causes depression, conflict, and even hallucinations. The solution? Rigorous psychological screening and designing habitats with private spaces, virtual reality, escapes, strict daily routines. The body betrays us. Mars, 38% gravity might sound fun. You could lift boulders. But it's a medical nightmare. Muscles atrophy within weeks. Bones lose 1 to 2% of mass per month. Eyes deform from fluid pressure changes, seen in ISS astronauts. Immune systems weaken dramatically. The countermeasures are brutal: 2 to 3 hours of daily exercise, spinal compression suits, and possibly genetic therapies to prevent deterioration. The point of no return. Here's the darkest reality. Early colonists may never come home. Between the physical toll of readapting to Earth's gravity, the astronomical cost of return trips, potential DNA damage from radiation. Many scientists believe the first Martians will effectively be permanent settlers, creating a new branch of humanity adapted to alien conditions. Why bother? Because we must, despite every obstacle, thousands have volunteered for one-way trips. Why? Because this isn't just about survival, it's about evolution. Mars represents a backup for Earth's biosphere, a laboratory for unprecedented science, the first step to becoming an interplanetary species. As SpaceX's Starship and NASA's Artemis program race toward this goal, we stand at the threshold of history. Within our lifetimes, children may be born who will never see Earth except in pictures. So, after this journey across the rusted plains and into the subterranean shelters of humanity's future, would you sign up? Could you leave behind oceans, trees, and blue skies for a world where even the air is poison? The choice may soon be real, because Mars doesn't care about our dreams, but it will test them. And through that trial, we'll discover not just new worlds, but new versions of ourselves.